What is distribution? Distribution is the possible values a variable can take and the frequency of these values, how frequently can they occur. So for example, if you roll 2 dice and some of the face values that are coming on both the dice, the sum of the values act as your variables. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The values on the x-axis are the possible values of the variable that can happen when you roll 2 dice, and what is the frequency this particular value can occur. So for example, the value 2 can occur only once. That can happen only when both the dice have value 1 on their faces. Similarly, the value 12 can happen only once when both the dice have value 6 on their faces. A probability distribution is a list of the possible outcomes of this random variable on the x-axis and the corresponding values on the y-axis. So in this case, the probability that the variable will have value 2, basically the 2 dice will have the sum of total of 2 when thrown would be 1, because the frequency is 1, divided by 36, which is the total possible outcomes of this particular experiment. So if we draw a graph of all the possible variables and their probabilities, it is called as a probability distribution. Now the probability distribution can be discrete or continuous. Discrete when you're taking a discrete variable into consideration. For example, this was the case of a discrete distribution. And continuous when you're taking a continuous variable into consideration. Some of the common types of distributions are Bernoulli, binomial, Poisson, uniform, exponential, and normal. We'll look at the applications of some of these distributions in the subsequent use cases. First up, we have an in-store seasonal campaign. Now we have the AdventureWorks store, a familiar store that we've been working upon. In August 2021, they recorded that 12% of their customers bought 2 products together. One was Road Red 150 bicycle and the other was a red saddlebag. 12% of the customers have bought these together in the month of August 2021. The order shows that there are 40 more customers who are going to buy the bicycle. Now the manager wants to run a promotion campaign where he can offer this saddlebag together with the bicycle only if he knows for sure that there is a good probability that 5 or more customers out of these 40 customers will buy the saddlebag. The combo offer and the campaign makes sense for the product manager or for the store manager when there is at least a probability of 5 or more customers going to buy these combo together. So how can we solve this using the distributions? Let's look at it now. First up, let's analyze the data. We have the data that 2 products are bought together in a single transaction, which we call it as a trial. The probability of 2 products being bought is 0.12, 12%. 12 divided by 100 will give us the probability of 0.12, and it is constant across all the trials. Now 40 customers are going to buy a product, which means the number of trials is 40. The random variable x is the count of buys. So the variable can take values from 0 to 40 because that is the number of our trials. We want at least 5 or more customers out of these 40 should buy the product, which means we want the probability that more than 5 people will buy, and we need to find the cumulative probability of the variable. Now how do we decide the distribution? There are 2 mutually exclusive outcomes, buying or not buying. There are more than 1 trial, 40 trials in this case, and the probability is constant. All these are typical characteristics of a binomial distribution. Now if we use the formula of binomial distribution, we can calculate binomial distribution of 5 given 40 trials with the probability of 12%, that is 0.12, and using the true as a parameter, we get the value of probability as 0.65. We've used here a true, which is a parameter in Excel, because we want to because this will help us get the cumulative distribution of the variable that we are taking into consideration. So the cumulative probability for x less than or equal to 5, x equal to 0, 1, 2, 3, 4, 5 is 0.65. What we are interested in is x greater than 5, that is to the right side of x. So what will be the probability of x greater than 5? It would be 1 minus 0.65, which is 0.35. Now this gives us that the probability of 5 or more people out of 40 people buying cycles, the probability that 5 or more people will buy this product, that is the saddlebag, out of the people who are buying the bicycles, is very low because it's coming out to be 35%. So it does not make a lot of sense to run the campaign.